Hi, so welcome to the presentation on big data and Hadoop. Today we will talk about what is Hadoop and what is big data. We will try to demystify the jargons. So in the complete presentation of 1 hour, we will just try to understand the word and nothing else. Right. So in this presentation, we will cover the topics: the meaning of big data, what are its characteristics. Then we will talk about a case study for a retailer company. Then we will see why do we need a new file system. So it's going to be a distributed file system, and that is all about Hadoop. Then we will talk about the characteristics and a brief history. So where we started the big data world and how it has evolved. Then we will talk about the core components, what are there in big data, and its components like Hadoop distributed file system, then MapReduce, and all the softwares they are present in the ecosystem. So what are the limitations of big data? So it can't be implemented everywhere. So what are the use cases of it? Then the softwares present in the ecosystem, and why do you want to move to Hadoop? Then future of big data. So where we are and where we want to go. And then a case study for Oracle Big Data Appliance, and which is we are going to implement in Hadoop. Right. Now, so let's make the class more interactive. So what are your expectations out of this class?
Like firstly, the clear visibility about the big data, what exactly it is, because we have heard in last few months about more about big data, but I have not had like clear picture of what exactly it is, how it works, how it's going to be implemented, how it's going to help us. So that's my expectation.
That's good. So the complete session is just to understand and demystify the word big data. So that's the only purpose of it. So after this class, it won't be a jargon to you. Good. So let's proceed. Now, here in the picture, it's saying that if it's big, then it's big data, and if the data is small, it is not a big data. No, that's just an indicator. Right. Some of you might have done some research on big data, and some of you know it, and for someone it's just a buzzword. So let's go inside and try to understand what
according to the picture, if I look like the,
yeah. So it's a
not-
misconception that we feel that only if the data is big, then it's a big data.
Okay.
If the data is small, it's not a big data. So there are few characteristics attached to
big data.
the big data. So it's not only about the size.
Okay, if we are having a 1 GB data, then it might be a big data, or if we are having a terabyte data, then it might be a big data, right?
Yes.
Okay.
So it's not only about the size. If it's also attached to the velocity with which the data is coming, and a variety of the data, type of data that is coming to you. Right. So we will demystify everything. We will try to understand all the characteristics in the complete model. So let's see a video from YouTube that will give us a little bit introduction to it.
Okay, so you've probably heard of big data. But you may be wondering, what is it? And why should I care? For starters, big data is, well, big. Data has been getting bigger for a while now. From the dawn of time to less than a decade ago, mankind generated about 5 exabytes of data. In 2012, global data will grow to 2.7 zettabytes. That's
right. So far we have seen till
data is coming.
till the time to 2003 we have 5 exabyte of data, and in 2012 it has reached up to 2.7 zettabytes. Now we need to understand what is exabyte and what is zettabyte. So what's your understanding about MB, GB, and we know that GB is there, and then we have terabyte. And so what's the hierarchy? Do you have any idea about it?
Megabyte, gigabyte.
Yeah, we start with bit, then byte, and
bit,
then
byte,
we go
and
to
megabyte,
MB.
and
So 1 MB is around 1024
yeah, bytes.
bytes, and then we have GB, that is gigabyte.
Gigabytes.
So it's
Then we have
1024.
terabytes.
Then we have terabyte.
Terabytes.
Right. So let's see a complete chart of it. Yeah, after megabyte we have
we have
gigabyte,
one more, petabyte.
we have terabyte. So right now our hard disks are of nearly terabyte size.
Terabytes, yep.
Then 1024 terabyte is going to be petabyte. So if we see the numbers in the bytes, so it's million, till this it is million, this is billion, this is zillion, and then more than that. So these many zeros are there. So petabyte. So our data are in petabyte. So in 2003 our world's data, it has gone to exabyte, and in 2012 it has gone to zettabyte. So it is estimated that by 2015 the internet traffic will reach 4.8 zettabyte, and the complete data by end of this year it will go around 7 zettabyte. Yeah, only the internet traffic will be 4.8, and the main contributor to the data is internet. So in terms of YouTube videos, Facebook, then chats, then logs, and everything included. And then we have, after zettabyte we have yottabyte. Then after yottabyte it's brontobyte, and then geobyte. So by 2015 we will reach 7 zettabyte, and end of 2020. So every year it's growing by 3 times.
Every year.
Yeah, that is an average. So by 2015 we will reach around
7.
2050.
No.
And
2015.
2015.
7 zettabytes.
7 zettabyte.
Okay.
And it's growing at 3 times every year.
Okay.
Videos, photos, by 2015. One of the big reasons the data is getting bigger is that it's continuously being generated from more sources and more devices. And much of that data, like videos, photos, comments in social media forums, reviews on websites, and so on, is unstructured. That means the data isn't stored within structured, predefined tables. Instead, it's often made up of volumes of text, dates, numbers, and facts that are typically freeform by nature. Certain data sources are arriving so fast, there's not even time to store it before applying analytics to it. And that's why traditional data management and analytics tools alone don't enable IT to store, manage, process, and analyze big data. So we could just ignore big data. After all, is it worth the effort? Turns out it is. A recent Gartner study concluded only 10 to 15% of organizations will take full advantage of big data, but those that do will outperform their unprepared competitors by 20% across major financial metrics. And that's, you guessed it, big. But in order to generate that level of insight and competitive advantage from big data, innovative new approaches and technologies are required. Because the big data you're looking at is like a mountain, and you're trying to uncover those tiny but game-changing, competitor-smacking golden nuggets of insight and knowledge that transform how effectively you do business.
So that is Intel's video about the introduction to big data. So I have taken it from, I have just played it on YouTube. Right. So now after this video, so what's your understanding about big data? What is it? What it can be?
The data which is present in somehow a structured form as per the technology present, like I will see that to just use that data. If anyone want to implement that technology like big data in his automation, then data or data say or say the tools and technologies required should be like
Yeah. Before going in depth, I just want to understand uh, what do you understand about big data? If, what do you mean by big data?
data in a structured form.
Yeah. Right. So data can be structured, unstructured.
Unstructured, yeah.
Structured we would call the structured data to be whatever we have in our relational databases.
Mhm.
So it has a particular schema attached to it. We can query out of it.
Mhm.
But nowadays, the data is most of the data is unstructured
Unstructured, yes.
in terms of logs, in terms of tweets,
Hmm.
in terms of pictures. You upload your lot of pictures, people like it, people dislike it, and you have a lot of videos in YouTube and everywhere.
Mhm.
So these are unstructured data.
Mhm.
So big data. So the data
Mhm.
where which is very big in size, which is very tedious to store and process. So this processing power is also very important. So we can store data, but how you are going to get insight from the logs or the clickstream data or your tweets? How can we do the sentiment analysis? That is also a reason of getting the big data problem. So we have a lot of data. So that is big data, right? But the problem is storing as well as processing and getting insight out of it.
Can you just pardon?
Yeah.
I didn't get the big data word exactly which you did.
Right.
Yeah.
So let's see the definition. So it's saying that big data refers to collection of data sets in terms of data set, in terms of structured, unstructured and semi-structured data. So all the data set we have, it's so large and complex that it's difficult to store and process. So suppose somehow we get our big systems and we store the data, but how can we get the processing out of it? We have lot of likes and dislikes in tweets, right? So how you can get a conclusion that a particular product is working well or not? So we have to do sentiment analysis using our traditional data management system.
That is
We-
not possible, I think.
Yeah.
With the traditional
So
way.
we can just store it somewhere in your dump in your desk. That's it. But you can't put it in a relational database management
Because
system.
it required a structured
A
that
schema.
data in the structured form.
Yeah. So that is required, and that is not possible in our normal systems. So the data is dumped somewhere, but we can't analyze it. We can't get the benefit out of it. So, so big data problem arises from here in terms of the large volume as well as the processing power we don't have. So big data implementation and big data solutions will provide you both the solutions in terms of storage and in terms of processing. So it's a good definition about big data given by Apache. Right. So got some clarity what big data refers to?
Yeah.
Right? It's collection of data so large that it's very difficult to store and
Process
not
and
possible to
traditional.
process. So we can process that data. Using big data solution, we can process it. There should be some solution. So let's see. So how we are getting such huge volume of data? From social networks like Facebook, Twitters, tweet, and then from all these social medias, we are getting a lot of data. Right, LinkedIn, they are generating huge volume of data. If we talk about Facebook, it generates around 2 petabyte of data every day. So we are storing that data, but we need to analyze that data. If we can analyze, we can generate revenue out of it, doing the sentiment analysis, how the products are performing. If a company, Coca-Cola, they can do the sentiment analysis and they can increase their sales. They can get revenue out of it. Okay, nowadays we have a lot of retail data, right? And the online sports, that is Amazon, eBay, Flipkart, all these, right? So if we try to understand the customer's behavior, what are the products they are checking, what we can recommend, that what other people are seeing, what people have bought, what their friends have bought, so this can increase sale. So we need to get that data. So that is the click stream data. Analyzing this, the revenue can be, a lot of revenue can be generated. So that is the area where we need to explore more. And clickstream data is very huge. It's analyzing where you are going, what products you are seeing, what your friends are seeing, and what are the recommendations of it. So it's generating huge volume of data. Airlines. So a simple normal engine, aeroplane engine, it generates around 1 terabyte of data every hour. Just think about the huge volume of data.
Airline engine.
Yes.
Huh?
It generates, it checks all the functionality of the all the appliances used in the aeroplanes, and it generates such huge volume of data. Just try to think about the flying owls in the world, and that much data is generated, and they are stored, dumped, and few days those are deleted. Right. So it generates huge volume of data. For a flight from India to US, it's around 11 hours. So a single aircraft is generating that much of data. Just think of the flying hours in the world. There are a lot of data. Banking data, it's huge. Stock exchange data, it's huge. So the hospitals, hotels, geographic locations, sensors, CC cams, government data. So there are huge volume of data we are generating every day. And the data world is becoming more and more. So we need to analyze and store these data and get benefit out of it. So only the analysis on that will generate revenue. So it's all about money. If we just store it, dump it, and archive it or delete it, that's of no use. If we can analyze it, then only we can earn money. So if we think that we are in 100% of data world today, whatever data we have, it's, if we talk about, it's 100%. Then 90% of the data is generated in last 3 years.
Okay.
This is true. In 2012, we have around 1.2 zettabyte of data.
Now we are having 4.8 zettabytes.
Yes. So every year, it's increasing by 3 folds. Just think of a scenario in 1990s. You have a PC, right? So what was the hard disk capacity at that time? It was 1 GB or 10 GB or 1 to 20 GB, somewhere like that. Because at that time in the commercial, in the local market, so it didn't came as a household product. For the servers it was there, but for local market it wasn't. So it was 1 to 20 GB. How much was RAM? It was 64 MB.
64 MB, one like 512 MB, like this.
Yeah, 512 it came.
In 2006.
In 2000. In 1990s it was
in MBs.
In MBs only. In 64 to 128 MB, something like that. Right. And what was our Ethernet connector? It was 10 kbps. So now think of current world in 2015. Our hard disk capacity has increased from 1 GB to 1 terabyte. So it's just 1000-fold. Our processor, it's a quite faster i7, i5 processor with megahertz around 200 or 250 or 300 somewhere megahertz.
Yes.
And our RAM, we are using 4 GB RAM at least.
Yes.
4 GB, 8 GB,
8 GB.
somewhere like that. And previously we had 64 MB. So, and our Ethernet connectors, The adapters and the connectors, they are nearly in 100 Mbps or in GBs. We have giganet Ethernet adapters. So the processing speed and the transferring speed is more than 1,000 times. So this way, as we have increased the capacity of processing power, so we are storing the data as well, and we are generating in terms of our all the activities. So that's why our data structure, the complete database are increasing. And it's not for an individual, it's for all the people in the globe. So that's why the traffic is increasing in such a tremendous rate. So we have gone through the chart, that hierarchy of how we are the data, the complete table of the data. So right now we are in the zettabyte level, and within few years we will reach in yottabytes. Right. So what are your understanding about structured data and unstructured data?
Structured data, like it's a relational data. We having certain relation in between the columns and the rows, or say we are having any particular schema around that.
Yeah. Right.
So that means it's structured data.
Yes.
And and from the structured data we can like query as we require the data.
Yeah, as schema is attached to it, you can just query whatever you want and get
But
your
from the
analysis.
unstructured data, it's very hard to get any insights or any information from that, because like it's not any structured form. We can't query on that. It's not relational. We have to build a relation in between those rows and columns. And it's like all that.
Yes, that's right. So all the videos we are uploading, videos we are getting, all the pictures we are getting. So these are unstructured. If we talk about the tweets or the logs, a lot of logs are generated. The clickstream data. So all this data we are getting, these are unstructured data. Just think of any organization. There are presentations residing, right? So you have around, suppose 1,000 presentations in your database. So can you analyze it? Can you find out of the 1,000 or 10,000 presentations? Can you do an analysis if you want to find a particular slide, or there are a lot of slides and you want to get some insight out of it? Suppose someone has left the company and you need a particular subject or particular thing, you know that that's there. So out of the 10,000 presentation, can you find that presentation where that topic is mentioned? No. So these presentations are also unstructured, so you can't get insight out of it. Think about emails. In your organization, there is, suppose the data for emails is in terabytes, and getting access to an email is unauthorized for a particular person. But think of a situation, there is some emergency, or you as an enterprise level, you want to get some insight of something from the email databases. So you can't get out of it. Right. Using big data, you can get insights out of it. There are a lot of documentations there, so you can get insight. Right. So these are unstructured data. So there is another world called semi-structured data. What it can be, which has some structure attached to it, not completely structured.
Like we can mold the data according to our need somehow.
Just think of XML or a CSV file. Do you feel that in a CSV there can be some structure?
Yes, because we are having the data in columns, in rows.
Yeah. So you can make out that there is some sort of structure residing in a CSV.
CSV, yes.
Just think of XML. There are tags.
Yeah.
It has some structure. So these type of data we can refer to as semi-structured data.
Semi-structured, okay.
There are files, JSON files, JSON. So that's for JavaScript. Java can generate that type of data. JavaScript. So that's also a format for storing data.
Oh.
So these type of files. If we talk about logs,
Mm-hmm.
does it have a structure?
No.
No. So this is completely unstructured
Unstructured.
data. We can do an analysis on it.
Mm-hmm.
Think of emails. What do you feel?
Yeah, it's somehow structured, like to whom it's coming, when it's coming.
Yes. That's
Somehow,
little
like
bit.
semi-structured.
Yes.
Mm.
It has about the body that is completely unstructured.
Mhm.
But in terms of
The sender, receiver,
yes,
and the
time,
time,
stamp, when
yeah,
it is
when it is
seen,
coming from, when,
right,
yeah, it's like somehow
from which
semi-structured.
server it's going, from which server it's
Mm.
coming. So
Mm.
there is some structure reference to it.
Mm.
Right. So that's also an example of
Mm.
semi-structured data.
Mhm.
Right. So once we have got the understanding of it, let's move further. So what's it saying? 2500 exabyte of new information in winter 2012 with internet as primary driver. Digital universe grew by 62% last year and will grow to 1.2 zettabyte
this year.
in 2014.
Mm.
Okay, right, by 2015 end it is estimated that it will reach from 5 to 7 zettabyte.
Mhm.
Yeah. Now what we have little bit understand what is big
Big
data
data.
and what is the problem regarding that.
Mhm.
Now what are the characteristics of big data?
Okay.
What can be the characteristics of big data? What do you think?
The processing speed.
Hmm.
Like
What are the
for,
characteristics?
like
Which data can we can call big data? Which type of data?
semi-structured data.
Yes, semi-structured, unstructured.
Yeah, any kind of data we call big data.
Yeah. So
Whether it's
as of now,
structured.
our understanding, our thought is that
Mm.
if the data volume is big, then we will call it big data,
Yes.
right? That's
Yes.
our perception.
Mm.
So let's see a video and try to understand what are
Big data characteristics.
yeah.
Big data is often characterized using the three V's of volume, velocity, and variety. Here, volume poses both the greatest challenge and the greatest opportunity, as big data could help many organizations to understand people better and to allocate resources more effectively. However, traditional computing solutions like relational databases are not scalable to handle data of this magnitude. Big data velocity also raises a number of issues, with the rate at which data is flowing into many organizations now exceeding the capacity of their IT systems. In addition, users increasingly demand data that is streamed to them in real time, and delivering this can prove quite a challenge. Finally, the variety of data types to be processed is becoming increasingly diverse. Gone are the days when data centers only had to deal with documents, financial transactions, stock records, and personnel files. Today, photographs, audio, video, 3D models, complex simulations, and location data are being piled into many a corporate data silo. Many such big data sources are also unstructured and hence not easy to categorize, let alone process with traditional computing techniques.
So, right. So, as of now, our understanding was that the data that is very big is big data.
Big data.
So, there are few characteristics attached to it.
Mhm.
So, another is the variety of data.
Mhm. Variety, volume, and velocity.
Right.
Three V's. Mhm.
Variety, any type of this, movies, pictures, tweets, logs. So different variety of data is coming to us, and the velocity with it is coming. It is very fast. Right. We need to, with that velocity, we need to store it. We need to process it. In the runtime, suppose in a um, retail site, So you are viewing something. So you can see that it has started understanding your clicks. It has started generating result and giving you recommendations. So it will say that what your friends have bought, the people who have seen those products you are seeing, what they have bought, what are the products they have seen. So it's a machine learning algorithm going on in the backend. So we need to analyze the data with a variety of data, and we have to give the recommendation in order to generate money. So companies who are analyzing those data and trying to get advantage of big data problem, they will generate more money. So these are the characteristics. Let's see a picture. So generate given by IBM. It's saying the 4 V's of big data. One is volume, so you understand it, the volume. About the variety. Variety is different types of
the
data.
sources from which data is coming.
Yeah, it can be videos, posts, everything. Now the velocity with which data is coming to us. So in every industry, in terms of tweets, in terms of pictures, in terms of videos, so the velocity with which the data is coming so fast, it need to be analyzed every time. So just think of an aeroplane engine. So in an hour, it generates 1 terabyte of data. So our systems should be so much advanced so that the data we are getting from the aeroplane engine, that need to be processed in the runtime, and it should give the recommendation. If there is some problem in some of the wings or some of the machines or engines, it should give the recommendation to the pilot that there is problem, and it should forecast that it can run up to, if there is fuel deficiency or anything, it should give you the recommendation. You can
how
forecast
soon you
that
can
thing.
land, how soon
Yeah.
you can land. Okay, cool.
So we need to take the full advantage of big data to get advantage out of it. Now there is another term introduced by IBM, that is veracity. It's talking about the uncertainty of data. So there is one example. It's saying that 1 in 3 business leaders don't trust the information they use in decision making. So they need to validate the data you are getting some analysis. Then where is the benchmark? You can match, saying that this is 100% correct data. You are generating some data. You have done some analysis, you say that sales has gone to 20% this year. So how you are validating that data? So there is some uncertainty in data. So that is also part of big data.
How?
Yeah. Suppose you have analyzed and said that your sales are 20%.
Okay.
Right. So are you validating it with something? So how can you be 100% sure that whatever the percentage you are saying, that is completely correct?
You need to analyze from the data.
Yeah, you have analyzed it once and you have generated some result. So how you are validating? So there is some uncertainty. So as per the research by IBM, they say that 1 in 3 leaders, business leaders, they don't trust the data, trust the information they use to make the decisions. They are not completely sure. So right in Dunnhumby, so Tesco is doing its own analysis and Dunnhumby is doing some analysis, right? So now Tesco has option that they can validate whatever they are doing or whatever we are saying. They can match the data. They can match the results. If it's matching from 2 different sources, then only that's validated, right? But if they have just a single point of checking, they are not 100% sure that the analysis they have done on the data is correct. So there is some uncertainty attached to the data. So that term is called the veracity. Right. So these are the 4 V's of big data. Now let's see some of the big customers of big data. So in retail industry, it's implemented. We have clickstream data as well as we have the online data, and the tills, the transaction in the tills that generates huge volume of data. Just think of Kruger data we have in the bank. So it's huge volume, right? Now the data generated by Facebook, Yahoo, Google, eBay, they are also big data customers. They're analyzing. Just think of Google. It's processing once you do a search in Google. So just think about Aadhaar card. It's the biggest biometrics database in this world. So thanks to the population of India, so we have reached so far. Per person, it's going around 5 MB of data. So we have retina scan, we have picture, we have our fingerprints. So a lot of data is there. So it has implemented big data.
Okay, Aadhaar.
Yes, all the data, the database used is the MongoDB.
Okay.
That is a NoSQL database, and all the data is stored there. So big data has been implemented in a lot of places. In telecommunication, it has been implemented. In the banking and financial sectors, it has been implemented. So yes, we were talking about the Google. Google processes around 2 billion rows, 2 billion data within few in 0.2 seconds or 0.3 seconds, right?
2 billion data, it's in GB, megabytes, what?
2 billion records.
2 billion records, okay.
2 billion rows record, it's processing in 0.2 seconds or 0.3 seconds whenever you do a search. So that much fast it is. So it has also implemented big data. So big data has been implemented in a lot of places, and it's being used everywhere. Let's move forward. So this is a case study done on a retailer, that is Sears in US. So they have some problem. They wanted to get more insight in their business to get more advantage. They wanted to forecast their indicators, and they want to do more precise analysis on data. So that was their requirement. So at the time they were using Teradata, Oracle Exadata, and doing the analysis on SAS. So that was their structure, right? How they have achieved those functionality? They have, so the problem was that they have huge volume of data, and all the data was there in their warehouse just for 3 months. After 3 months, they were archiving 90% of their data.
Exactly. I have a question. Like,
Yeah.
what does the meaning like we are archiving the data, and like what exactly it is?
Right.
In which form we are like archiving the data?
Right. So for this company, they had around 2 petabyte of data. It's saying yes, they have around 2 petabyte of data, right? And the data is stored in their OLTP system, transaction processing system, and they were just doing the ETL process and storing it in their data warehouse. Now, in the data warehouse, the data is populated every week or every day, and that is being generated, compiled every time. They have some capacity. So every 3 months, what they are doing, after every 3 months, they are archiving the data. Archiving means that they are taking the data out of their data warehouse and they are just storing it in some tape storage or somewhere out of the data warehouse. They are just keeping it. That's it. So this means that they can do any analysis on that data. So it's out of the data warehouse. But there are few analysis that is done for last year, right? So for the older data, they can't do any analysis, so they are not getting that advantage. So they wanted to keep all their data so that they can do analysis. So that was their issue. How they have resolved it? They are collecting the data same way. They have implemented big data solution. They have put the Hadoop in between, Hadoop storage. So out of that, in their RDBMS, they are just putting only 3 months.
One more question, like what exactly the Hadoop is? It's like a software, it's a machine, what?
Okay. Hadoop is a framework.
Is a framework.
We will go into details about it.
Okay.
It's a framework which help us to store the data and do analysis on the data.
Okay.
So it has a lot of softwares attached to it. And yeah, softwares do give us all the flexibility to do all our data analysis and data related problems. Right. So we have implemented Hadoop in between, and then we are doing the exactly same thing whatever we were doing earlier. We have the ETL process, and we are putting the data for 3 months only in our data warehouse and doing the data analysis on 3 months. But if we need the older data, we can directly pull it from Hadoop. So there is no archiving right now. So this way, their issue was resolved.
Okay.
They have all the data, 100% of the data. They have implemented 300 node Hadoop cluster, and they are getting all solutions, all the analysis on completely. Right. So far, yeah. Now we will discuss about what is distributed file system. So prior to that, why do we need a new sort of file system? So that's our question. Right now we are storing data and we are analyzing data. Why do we need a? So what do you mean by a file system?
File systems like that there are several departments, there are several people who are storing data in their own folder. Not in a one machine. Like if a data is big, then it can't be stored in a single node. So we require different nodes. But it appears for us that it's a single node. Like
Just a minute. I'm just talking about the file system. Simple. If you talk about Windows operating system, there is a file system.
to enhance the to enhance the searchability of a system.
Just for storing, we have completely raw hard disk. We have to use some file system to store data or make it working. So prior to Windows 2003 or 2000, we had FAT file system. Right now we have NTFS file system. So these are the different file systems. For Linux, it's Z file system. For Unix, so these are the file systems to store data. And we need a new type of file system that is distributed. So why do we need it? So let's talk. Okay, prior going to that, let's see a case. Suppose we have a single machine, right? Which has some processor, a single processor. We have 4 hard disks. So we were calling it 4 input-output channels. Suppose we have implemented 4 hard disks and it has a Ethernet card for 100 MB per second. So this means that it can transfer data at a speed of 100 Mbps, right? Now we need to read 1 terabyte of data. This is our requirement. We want to process 1 terabyte of data. We have a single machine which has 4 IO channels and whose channel speed is 100 Mbps. How much time it should take to process 1 terabyte of data?
45 minutes.
Yeah. So it's saying that 100 Mbps, 100
100
MB per second. So we need to transfer this data to from terabyte to MB, and in terms of minute, we need to, from second, we need to transfer it to minutes. Right. So 1 terabyte. So roughly, instead of 1024, we can call it 1000. Right? So 1 terabyte is 1000 gigabyte, and 1000 gigabyte multiplied by 1000, that is MB. So we have 1 million MB.
Then it's
Just divided by
100,
divided by 4, divided by
60
60.
to get it.
So in from seconds we are going to minutes. So it will take 45 minutes to process that data. Not even processing, just to read 1 terabyte of data. So that's quite simple. Just to read 1 terabyte of data, a computer will take 45 minutes to read it. And after reading, it will start processing, and it will take some time. Just think of a scenario. We have 10 machines. The 1 terabyte of data that is distributed in 10 machines. If you have some way to distribute the data equally in all the 10 machines, suppose it's a hypothetical scenario where we are saying that we're distributing the data, and the configuration is same. So can we say that it will take, you can just divide it by 10.
No.
It will take 4 minutes,
4 minutes.
to read the data.
I think it's not possible.
But we have distributed the data equally in 10 parts. So this means that is going to be 10 GB of data everywhere. This machine was
for this file system, like we are doing the parallel connection or a serial connection.
Let's see. I'm just talking about a hypothetical scenario. We have 1 terabyte of data. We have just distributed it. Suppose this is 10 GB of data.
Got that,
divided by
what?
No, 100 GB.
100 GB.
100 GB of data, it will take 4 minutes. So if anyway, if we can distribute the data equally, and just to read the data, it will take, just divided by 10, it will take 4 minutes.
4 minutes.
Okay. Instead of 45 minutes, it's just divided by 10. Okay. Now, just in terms of this, just think of a file system where we can distribute the data equally, and then processing it somehow. So here, just to read it, it will take some time. To process it, suppose you have generated a SQL statement to process data on this machine, right? And somehow you are able to send that SQL statement, and using mapper and reducer, you send the same program to all the machines and do all the calculations on a small bit of data. Get the data using reducer and club them together.
Okay,
and
that's
generate
map reducer
data.
you're talking about.
Yes.
Okay.
So if you have some type of system like this, so you can get the data in lesser time. So you are distributing the job in few nodes. So that we can we do like that?
Yes.
If we have some way to do this type of process, then we can reduce the time. So this is why we need a new file system. The file system we have right now is processing this way. So we need a new type of file system which can distribute the data, which can do all the processing at that end, distribute the program, send the program to the nodes, get the data processing at that node only, and get back to us. Right now, in our normal system, in Exadata or in our relational database management system, we are writing some query, we are fetching the data to the processing engine, and then just think of here. No, I will talk about when we will go to the Hadoop file system. Then we'll talk about it in details. So we need a distributed file system to reduce the time of processing. Let's see what is Hadoop. So Hadoop will provide us the distributed file system to do that type of processing.
Okay.
So is it making sense how we can reduce the processing time?
But we are just distributing the jobs to different nodes.
Yes. This way we can distribute. So this gives us a case where we need the Hadoop
Okay.
to create a distributed file system.
File system.
So let's see what Hadoop is all about. So let's see.
There are many
अभी नहीं होते
Okay. Got it. Okay.
this first one